All right, so for today's lesson in Chapter 5, multiplying by two-digit numbers, we're going to revisit something that we learned last chapter. And y'all did really good on it, so I'm confident you're going to do really good on it today. So we're going to use the distributive property to multiply. Now, remember, we started out with the strategies, multiplying by multiples of 10, 100, 1,000, so on. Then we rounded to estimate products. And remember, when I have two multi-digit numbers that I'm multiplying together, I really need to round both factors to the greatest place value unless my directions tell me differently. And now we're back to the strategy of the distributive property. Remember that includes those steps include area models, arrays, partial products. That's all a part of the distributive property. And remember our three steps for the distributive property: decompose, multiply, and add. Now, when we get to multiplying by two-digit numbers with this distributive property, in area models, it can look a little different because we can decompose either factor. We can decompose both factors. But today we're going to look at just decomposing one factor. So here's kind of your review from last chapter. This is what we've done before. So you have used the distributive property to find a product of a two-digit number and a one-digit number. Now, because we're kind of leveling up a little bit, they added something a little extra. But to me, it's a good thing because it kind of says, hey, this is what I'm about to do. So we are going to multiply 3 times 11. Now, I know the product of 3 times 11. You should know the product of 3 times 11, but we're not worried about the answer, right? We're worried about the process. How do we work this distributive property and understand it and get the question right? So we take 3 times 11, and now this is a chapter 4 review. We're reviewing multiplying by a one-digit number. So what we did was we decomposed our multi-digit number, the 11. Now, here is that extra step I was talking about. This is what they did. They have said, hey, I'm not going to mess with my 3. I'm going to leave my 3 alone. But I'm going to decompose my 11. I'm going to take 11 and I'm going to break it into the place values. I'm going to do expanded form. I'm going to say 10 plus 1 because 10 plus 1 is the same as 11. So this is the extra step. But really, it's just kind of like a heads up, a warning sign. Hey, this is what I'm going to decompose. Then we go to the steps that we're used to. After we decompose, we multiply. And we say 3 times 10 is 30. 3 times 1 is 3. And then I add the two partial products together, and I get 33. Now, here's my area model out here to the side. I decomposed 11 into 10 plus 1 on the top right there. And then I multiply 3 times 10 is 30. 3 times 1 is 3. I add those together and I get 33. Sorry, it doesn't pick up my finger too well on this board. So, of course, we kind of can infer that we can also use the distributive property to find the product of a two-digit number and a two-digit number. So here's the thing, is no longer am I dealing with this one digit. Now I've got two digits. So that makes this step right here, this heads up, kind of even more important because we're telling people which factor we're going to decompose. So let's take a look at this. So our first example, it is actually broken up into 3 steps. We do this really quickly in one step, but they wanted to break it down. So let's take a look. This goes on to the back of your page. So we're going to find 12 times 15. Now, since they're walking us through this, we can't just pick any number we want to pick to decompose. We've got to pick the number that they have decomposed later in the problem. So we're going to decompose this 15. Now, it's easy to say, oh, well, we decomposed the biggest number. No, you can decompose the 12, you can decompose the 15, or you can decompose both the 12 and the 15. But again, we're not doing that today. We're only decomposing one of our factors today. So The number that we're going to decompose is going to go on the top. The number that stays the same is going to go on the outside. So here's my dimensions. Here's my area model or my array. So let's move over here to step number 2. Separate the tens and ones. So now we're about to decompose. We're going to decompose that 15, and we know we're going to pull it apart in expanded form as 10 and 5. So there's my original problem that I have to write. Here is that extra step. Hey, I kept 12 the same, and I have to keep that multiplication symbol there, but I decomposed 10 plus 5. Now notice 10 plus 5 is in parentheses. Why is it in parentheses? Hopefully you are answering in your head, it's because I have to add 10 plus 5 back together before I can multiply it to 12 if I was working out this initial problem. It's showing that the 15 is what I decomposed inside those parentheses. So back to what we know, my number that I do not decompose is going on the outside. Can't get it right. That's supposed to be a 12. My decomposed number is going to go on the top, 10 and 5. So I decompose. Now I need to multiply. I'm going to work it all out on step 2, and then we'll plug it in on step 3 because it's basically the same. Instead of working ahead, 12 times 10, we think of it as 12 times 1 if needed. We should know this. 12 times 1 is 12. Then put that 0 on the end. I get 120. 12 times 5 is 60. And then after I decompose, I multiplied. Now I need to add 120 plus 60 is 180. It's supposed to be an 8. All right, now let's see what that looks like with our distributive property down here when we take away the area model. Remember, everything is the same, except I have to put this extra part in there. Hey, I'm keeping my 12 times the same, but I'm decomposing my 15 into 10 and 5. It's expanded form. Then we go back to what we know how to do. When I multiply, I multiplied 12 times 10, I got 120. 12 times 10, 120. Then I multiplied 12 times 5, and I got 60. 12 times 5, 60. And then 120 plus 60 is 180. So 12 times 15 is 180. So this is a good way to ease into the standard algorithm because it can get a little tricky. Now, just be aware on classwork and on homework. Sometimes, because I guess their computer formatting wouldn't let them put it all in on the same line, and you'll see what I'm talking about. This is kind of my disclaimer, so if I refer to the disclaimer, this is it. Whenever they put their blanks, the one, because we multiply here, we multiply here. For some reason, they will drop this down below it, and it looks really weird, but we're going to fix that. It's the same steps, it just looks different, but we all know whenever it looks different, that kind of throws us for a loop. So let's do 2 more examples together. How would you use the distributive property to find 12 times 18, then find the product? Well, let's use our area model first to help us before we do the distributive property. Let me move it over just a little bit, just to make sure I have some space over here. Now, 12 times 18. Let's keep our 12 the same just because we did that on our first example. And then let's decompose my 18. All right, and I need 2 parts because I have a 2-digit number that I'm decomposing. So let's go ahead and let's write out this distributive property over here. My distributive property, I rewrite my 12 times 18 equals. Now, don't forget, we got to put in our extra step, which is why I wanted to do this now. Hey, I'm keeping my 12 the same on the outside, And I'm about to multiply it by what I just decomposed. I'm about to multiply it by 10 plus 8. All right, there's my extra step, but really it's explaining what's about to happen. Now, this is when you know your next step. You know that I'm going to need a group here and a group here. So I just wanted to kind of jump ahead and show you the similarities. Don't think that it's hard because you've done this before. All right, so now I need to multiply 12 times 10, 120. Remember that you should know this. It's a basic fact, but 12 times 1 is 12. Put your 0 on the end. 12 times 8, you should know this, is 96. So whenever I add these two together, stack and add it because it's not as easy as some of them can be, I get 216 as my answer. That would really on the outside of there, just out of brain. So let's take what we did and plug it into our distributive property. I said 12 times 18. Keeping the 12 times the same, I'm decomposing 10 plus 8. Now I'm about to do my steps that I should know how to do. I first multiplied 12 times 10. Then I multiplied 12 times 8. Whenever I multiplied 12 times 10, I got 120. Drop down your plus sign. Whenever I multiplied 12 times 8, I got 96. Don't leave off your plus signs. Y'all leaving off your plus signs. You need them. And then whenever I added, I got 216. So I hope it's coming back to you. I hope this is easy. I hope that one extra step doesn't throw you off. So let's look at another one. Let's look at this bottom one. I'll put the area model over. Oops, that's going to be too close. Over here for this one, making it kind of small. How would you use the distributive property to find 14 times 17? Then find the product. Well, let's do this one a little differently just to see how it would work. Normally, we have been decomposing the bigger number. Well, now let's decompose the smaller number. Let's decompose that 14 and see how it doesn't matter. It still works the same. So if I'm going to decompose 14, that means my 17 needs to go on the outside. It's supposed to be a 7. My 14 gets decomposed into 10 and 4. So let's go ahead and write this out to the side over here. All right. I have multiplied 14, or I am multiplying 14 times 17. I'm going to keep my 17 the same, but I'm going to decompose my 14. All right. Now my equal sign, and I'm ready for what I know how to do, hopefully. All right, so come back over here to your area model. 17 times 10. Think of 17 times 1. Then stick that 0 on the end from there. Then 17 times 4. Now here is the biggest difference with the distributive property with two-digit numbers. A lot of times you're going to have to stack and multiply because they're bigger numbers. 7 times 4 is 28. 4 times 1 is 4 plus 2 is 6. So I get 68. Now I decomposed. I multiplied. Now I need to add. Now I'm just going to come up here. 170 plus 68. That's a terrible 0. 8. 13. Carry my 1. 1 plus 1 is 2. So I get 238 as my answer. So let's go plug this in. 14 times 7. 17. I kept my 17 the same. I decomposed my 14 into 10 plus 4. The first thing I multiplied was 17 times 10. The second thing I multiplied was 17 times 4. Whenever I multiplied here, I got 170. Whenever I multiplied here, I got 68. And then whenever I added these together, 238. What's my answer? All right, so I hope this is pretty easy for you all. If you need to rewatch any of the parts, you are more than welcome to. But let's talk about some things before you get started on classwork. Homework. Tonight, we are going to complete all of our homework, front and back. You do have to draw an area model for each problem. And then for classwork, you do have to complete front and back of this. Now, some very important notes. So I don't have to grade a million different ways. We're going to look at what we need to decompose. So sometimes on here, when they've worked a little bit of the problem like they've done on number 3, they've already picked a number to decompose. They've picked 24. So that's the number that should go on top of your area model. So on number 4, now they've done most of the work for you on number 3. On number 4, you need to look and see, did they decompose a number? Yes, they did. They decomposed 19. So I need to put 10 plus 9 on the top. And I'm going to let you do the rest by yourself, because hopefully you should know. Now, on the ones that they don't help us out on, I'm going to tell you what numbers to decompose, so I don't have to do both ways whenever I'm checking your papers. So let's take a look. On 5, you're going to decompose 11, so 52 stays the same. 11 is decomposed into 10 plus 1. Same thing on your area model over here. Do the same thing. If you don't decompose the same number, you're doing double the work. Now, here is my disclaimer. Remember when I told you it was going to look weird? Normally, I would say 52 times 10 plus 52 times 1, and it would be out here beside it, right? Well, obviously, their computer wouldn't let them type it up there. So what you're going to do is you're going to write it just like I did, and you're just going to do a small little scribble through that. And now it should look the same. Let's go ahead and, or the same as you're used to anyways. Do this down here, small little scribble. So that way you get to multiply 52 times 10 here, 52 times 1 here, boom, boom. It's just a little off-centered. Multiplying what you decomposed here, multiplying what you decomposed here, boom, boom. All right, now let's look at this next one. We are going to decompose 22. So keep your 46 the same. 20 and 2. Area model, 20 and 2. Now, I'm not completing these area models because that's what you got to do. So don't just leave it blank because I did. Flip over to the back. You do have to use an area model. Now, if you want to just use distributive property, you can. Most of the time, though, we want to use area models because we like them better. Let's decompose the 12 on this one into, or sorry, no, don't decompose 12. Decompose the 15, keep the 12 the same. Sorry, that's what I meant to say. It's supposed to be a 10. That's supposed to be a 2. All right, and then if you use an area model, you can just, or either one, distributive property. You don't have to use both. Make sure you put your answer on the line over here. Write the multiplication sentence for the area model, then find the product. They give you an area model to use on number 8. On number 9, find the error. So before you can find the error, you need to draw an area model and see what happened to Tim. Correct his mistake. And the last one, the right about it, I do want you to answer this. Why is the distributive property appropriate for 2-digit multiplication? Think about why it works. This isn't, remember, we think way too hard about these questions. Think about why the distributive property works for both multiplying by a 1-digit and multiplying by a 2-digit. Think about those 3 steps of the distributive property. All right, Looking at homework, you do have to draw an area model for each of these. It does need to match your distributive property over here. They decompose 34 here. They decompose 22 here. You need to do the same thing to your area models. On homework tonight, area model. Now, they didn't pick one to decompose for 3 and 4, so I'm going to tell you which ones to decompose for 3 and 4. So you might want to go ahead and write that down. We're going to keep 18 the same and decompose 30 and 9. We're going to keep 17 the same and decompose 48. And I want you to decompose the same numbers out here on your area model. And this is that disclaimer. It looks weird. We're just going to fix it. Whoops, I fixed it in the wrong spot. It helped to fix it in the right spot, wouldn't it? Blank times blank. You should have enough room. Blank times blank. That way you're ready to boom, 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 whoops, boom. All right. And number 5, same thing. Got to draw your area model. Let's squiggle that out. Here and here. Area model. We are going to decompose 64 on this one. And then on this bottom one, to solve it, I want you to, whether you use an area model or distributive property, we're going to decompose 55 into 50 and 5. So let's do 16 on the outside. All right. So this is your classwork for today. I will also have this posted in Google Classroom. I expect you to get this done. I expect you to be on your best behavior. Remember, work hard and do better for Miss Jackie than you would even do for me. I love y'all. I miss y'all. And be problem solvers.